Any questions? The last thing we did. Yeah, Master set 3 is due on Tuesday. All right, let's talk about chapter 4. And this little just that comes back. It is, as mentioned before, what I consider the most important equation in all of physics. It is the basis of the more sophisticated equations that will show up later. Key things here, one, the only two vectors in the problem, and so therefore, whatever the direction of the total force is, and this is total force, wherever the direction of the total force is the same as the direction of the acceleration. So if I have an object right here that is moving in that direction, so velocity is in that direction, if I push on it that way, the acceleration and the velocity will be in the same direction. Because if I push on it that way, that's the force is in that direction, therefore acceleration. It will speed up. If I push this way, it will slow down. What will happen if I push this way?
Is that with the velocity still going that way?
Yes.
Would it flip or like turn?
Yes, it'll turn. Because remember, acceleration means it speeds up, slows down, or changes direction. So if I push perpendicular to it, it will change direction. All right. So let's do just a simple example to start with, and then we'll make it more complex as we go. So if that is a 3 kilogram mass, and the only force acting on it, this would be an example of other. I have a 7 Newton force acting on it. Assuming that is the entire problem right there, what is the acceleration of the mass? So, somebody just take a shot at it first. What is the acceleration?
Is it 0.428?
0.428. I appreciate that. You got it flipped.
No. 2.33.
2.33. So units.
Meter per second square.
Say it again.
Meter per second square.
Yes. All right. Let's see how we got that. We're plugging into this equation right here. So 7 newtons. Newton is a unit of.
Force.
Somebody said it very quietly.
Force.
Okay, several quietly, but we'll go with that. And so that's 7 newtons is equal to, well, what's the mass?
3. 3 kilo.
How do you know that's the mass? Was it what?
Because it says so on the box.
And how do you know that's mass?
Kilogram.
Yes, yes. When you see kilograms, mass. So 3 kilograms times the acceleration. So the math problem we're working with is just 7 is equal to 3 times A. We're trying to solve for A, so we need to isolate it, get it all by itself. So we need to undo however this is connected. Well, they're multiplying here. So you undo multiplication with division. So A is 7/3, 7 divided by 3 for the improper fraction fans, 7/3 meters per second squared, and for the decimal fans, 2.33. All right. At this point, I'm gonna do another simple example. It'd be really, really cool if all of you give the answer in unison. Tears of joy. Five Newton force, 2 kilogram object. What is the acceleration? It sounded like a single voice. That's how in sync everyone was.
Meters per square.
There we go. Now Newton, when he originally wrote this, didn't write F equals ma. He actually wrote acceleration as force divided by mass, except it was in Latin. This is modern notation for, in essence, what he wrote. All right, questions before I make it look slightly more complicated? Now, we do need to establish one thing that we didn't do here. I got a little slack. We had 2.33 or 7/3 meters per second squared, but it is a vector. How do we indicate the direction?
Is it either a plus or a minus?
All right, which way do you want to make it positive?
To the right.
Okay, so we can just write a little arrow that way and write positive, and it's understood to be positive if there's nothing in front of it. And we'll let that hold for this as well. Here we go. Making it look slightly more complicated. I'll keep that at 2 kilograms. I'll put a 10 Newton force there and put a 4 Newton force going back that way. What is the acceleration now?
Three.
Give me the whole thing.
Subtract. Subtract to.
Is it 3 to the right?
We subtract 10 minus 4.
Right.
So the force 6 Newton,
Okay,
and we divide 6 by 2.
right. I'm not disagreeing with the 3. I just want more than just the number 3.
3 meters
Meter per
per
second.
second squared.
Okay. Positive or negative?
Positive.
Why? Oh, you're saying that still holds? I got a couple people nodding yes.
There's more force going that way than back.
Okay, yeah, I'll agree, it is that direction, it's just a question of whether this red plus sign holds for this.
Yeah.
Sure, why not? So we'll keep that. So it is, I have 10 going this way, 4 going that way, so my net force is 6 newtons. So this is the same problem as a 6 Newton force to the right and a 2 kilogram mass. Or it also could be written as 6 newtons pulling on it instead of pushing on it. Those are all the same problem. And so we end up with 6 newtons divided by 2 kilograms. And I get 3. Now judging from this, I should have newtons per kilogram, right? And yet, more than one person, I believe, said meters per second squared. Why? Which is correct?
Both.
A meter second squared.
Both.
They're both correct? How can they both be correct?
Newton equal kilogram per meter per second square.
Absolutely. And as I believe mentioned before, a Newton, by definition, that's the three lines, kilogram times meter per second squared. So in terms of a quiz or test, either one, it doesn't matter. We'll do one more of those and then I'll make it a little more complicated. On our new board, we have no established positive direction. And the answer is
Minus 0.5. Negative 0.5 meters.
negative 0.5. And you were gonna say?
Negative 0.5.
What's wrong with that answer? Actually, there's two things that
Oh.
I, pardon?
Acceleration can never be negative.
Oh, it can be. I believe that was part of that lab that you had done in the last two lab periods.
There wasn't a unit on
Say it?
it? There wasn't a unit on the answer?
Okay, that's one of them. All right, so we got, this is what I was told, so what should the unit be?
Meters per second squared.
Okay. And the other issue is the negative sign. Why is it negative?
There's more force going in the negative direction.
Why is that the negative direction?
Because we did it thinking right was positive.
Yeah, we need to establish that though. That stuff over there, that's the past. Stop living in the past. I do that enough for everybody. All right, so let's establish the positive direction. Or you could just do it as 0.5 meters per second squared left, if you feel like writing. All right, questions before we make it more complicated? Before I make it more complicated.
So we wouldn't say, we wouldn't put it down as negative, we would just put right or left,
You could,
so we could put negative too.
yes, yeah, as long as you establish what the positive direction is.
Okay.
Or if I just said, what's the magnitude of the acceleration, don't worry about the sign. All right, let's make it look more complicated. Now, what is the acceleration? Flashback to probably 2 weeks ago. How to deal with a two-dimensional problem. How do you deal with a two-dimensional problem? Separate that.
Do we have to establish, east and north?
Okay, that's one way. Typically in physics, you don't, it doesn't have to be east and north, what, in physics,
Up and to the right.
okay. I hat, J hat. So let's just make I hat to the right, J hat up. All right, so what's the force act? So we're plugging into F equals ma. Newton's second law. Or shorthand, Newton's second law, N2L. What's the total force then?
3 N I hat plus 7 N J hat.
Is equal to 8 kilograms times the acceleration. So the math problem we're dealing with is basically 3 I hat plus 7 J hat is equal to 8 A. That's the math problem we're working with. How do you solve for A? And so my acceleration is, well, I'm dividing each of these by 8, not just one of them. So 3 divided by 8, you can leave as a fraction if you want, or do the decimal. I hat plus 7/8 J hat. And then it's just a matter of units. How would you write the units for something with a, I got a plus sign in the middle, how would you write the units? First, what are the units?
Meters per second squared.
Okay. How would you write them? There's two proper ways of doing it. All right, where should I write meters per second squared?
On each fraction?
Say it again?
On each fraction?
Yep, that's one way of doing it. So 3/8 meters per second squared I hat plus 7/8 meters per second squared J hat. And there we go. That is perfectly acceptable answer. Or 0.375 meters per second squared I hat plus 875 meters per second squared J hat. Again, for the decimal fans. Oh yeah, I've noticed, and this is not just this class, in labs, on grading labs, just do a quick double check before you hand it in, just to make sure that the decimal points can actually be seen. Some people just do it very quickly, and there's just this tiny faded little discoloration in the paper, which I sometimes assume is a decimal point. All right, and the other way of writing meters per second squared, or how else can you write the units here?
0.375 meters per to the right.
Wait, say that again?
0.375 to the right.
Oh, no, I'm just worrying about the units right now.
Newtons over kilogram.
Okay. Yeah, I guess it's a read my mind exercise. There is a different way of writing it. You could use newtons per kilogram instead of meters per second squared. If you want to write units just once, then you would write 0.375 I hat plus 0.875 J hat, is supposed to be an I. And then meters per second squared. If you wanna write it just once, you do need parentheses around the whole thing. If you don't put parentheses around the whole thing, then all you've done is add units to the second number. It's a minor deduction, but, you know, it's an unnecessary one. Or just tack it on to each term. All right, questions before I make it on Carver?
Would we write, so, you know, that was one way, in the previous problem, you said that we could also write it as, like, going to the right or going to the left?
Yeah, so if you wanted to do the direction that way, oh, sorry, did you finish your question before I just jumped in?
Yeah, I
Sorry.
was just gonna say what I thought it was gonna be.
Okay,
Oh, I thought it would be 0.375 to the right and then 0.875 up,
and how did you connect it? What
plus.
plus? Yeah,
Would that be the answer too?
yes. You prefer writing the words out than?
I was just asking because of the previous question. Or,
Okay, yeah, it is the I hat, J hat is just because we don't feel like writing that much. That's pretty much true for all the symbolic language. If you ever look at, math problems, like several hundred years ago, they would not have given you, well, like we had before, I guess over here. They would not have given you this. It would have been totally written out. And what number times 3 will give you 7? That kind of thing, where they write it all out. And then you start bringing in quadratics, it becomes, this is so much easier. At least for me. All right. Other questions before I make it?